Okay.
1, 2, 3.
So then I think we are ready to start the session. If everyone are getting in. Okay, so welcome to this session. We have two speakers today. First off, we have Peter Prydel to talk about his EPSG.io and projections and coordinate systems. So, welcome.
Thanks. So good morning, everybody. I'm Peter. I'm from a company called Glocan Technologies in Switzerland, and I'm here to present a system which we have developed for searching in coordinate systems and for a basic preview. So what is the EPSG.io? It's a free online full-text search. The problem which we were facing was how to search in the coordinate systems through the full text. So if people know text which is in the description of the coordinate systems, how they can identify the exact definition to use it in the software. A typical problem which we had is that we receive data from a country we don't know enough about. And it's missing a special reference system, and we can't process the data. This system is designed to solve this problem. It indexes the official EPSG database, so data which are freely available at EPSGregistry.org, and also S3 database through the GDAL scripts. It's designed for discovery of all the parameters in the EPSG, not only what you need for the special reference system, for the coordinate systems, but also for other attributes which are in the database. And it supports exporting of various data formats. It's an alternative to specialreference.org, which was a system designed previously. But special reference.org didn't have the full text search, and it didn't have support for different transformation systems. So those are two main differences. Before I start, I wanted to know who knows what is geodetic datum here? Okay. And who is using specialreference.org? Who has ever used EPSG.io? Okay, thanks. So, and maybe a few questions more. Like, do you want to? Whose problem is to find a coordinate system for data which is missing it? Like, do you have a problem that you receive data which is missing coordinate system and you are searching for the coordinate system? Please raise your hands. Okay. And who is just interested in the coordinate systems in general on the talk or on the searching on the system? Okay. So first, the basic use of the system, like how a basic use looks is if you end up on the front page of the EPSG.io, you will see a search box like on Google where you can type country, code, or name of the coordinate system. If you do this, and the system automatically provides you with the search results, like in a full text search. So on the left, you see the different coordinate systems appearing or in use on the area of the country you have discovered. When you click on one, it's presented on a detail page where you can see a preview of the center of the coordinates. So you see how many digits are in the given coordinate system, what is the rough range of the coordinates you have available, whether it's projected coordinate system or not. And there are export in different formats available on the site. So you can get the well-known text, as you see here, with all the technical information about the system. And there are also exports in Proj4, which you can copy and paste into another external software like open source QGIS or other systems. Or also outputs for Mapnik or, for example, PostGIS with an SQL query where you can add the system into your database, so it's supported. The system has also a preview, so a basic user can just identify on a map a place, and it gives estimated coordinates in the given coordinate system. So here we are zooming to our office in Switzerland, and on above you see the coordinates in the Swiss coordinate system, which you can copy and paste and use for whatever you need. You can switch the maps, and it's just like if you are searching for coordinates, it's good to have this sort of reference where you see the coordinates and you see them on the map. This is another tool which is available there for basic use, and that's for transformation inside of the web browser, where the coordinates you picked on the map or you typed can be transformed into a different coordinate system inside of a web browser. You have seen switching between angles, and now like a formatting of the degrees. You can choose different coordinate system to transform it. So if you are just in front of a web browser and you need to make a basic fast transformation from one coordinate system to another, this is pretty handy tool to solve the problem, because you can find any coordinate system and you can transform the numbers from one to another in a browser. So this is like the basic core functionality of the system. But there is more. But before we start, there was, I guess, for a programmer who has no degree in cartography, you need to know a few terms. So just a short crash course. The coordinate systems are typically either geodetic, which are three-dimensional, latitude, longitude, or lambda phi, typically measured in degrees. That's what most of the people think gives precise location anywhere on Earth. The other group of the coordinates are projected, which are measured typically in meters or feet, and are two-dimensional on a plane. Both of these coordinates define somewhere the origin, together with so somewhere is 0, 0. This differs depending on the coordinate system definition, and the way how you define the 0, 0 and how you adjust the ellipsoid, the approximation of the shape of the Earth, and fit it to the geoid, which you see on the picture, defines the datum. So datum is a way how if you have an ellipsoid, somehow deformed sphere, you rotate it and fit it to the real terrain you are trying to approximate, and you define where is 0, 0 on this ellipsoid. That's the geodetical datum. This is the first step of doing projecting coordinates, where then you define on this ellipsoid, which you rotated, you define a plane into which you will project. So it's either a plane or conus or other shapes, and then mathematically you transform the coordinates from the ellipsoid to the plane. So that's like a shortly given crash course. I hope the geodets here don't mind. EPSG.io in the advanced search or in the advanced functionality gives you power to discover all these parameters which are defining datum, which are defining ellipsoids, which are defining projections. Where are the origins on the ellipsoid, and where are the origins in the 2D projection? So if you combine all of this together, a software is able to transform the coordinate system to the real location where you know where you are. And therefore you can transform from one coordinate system to another, choose the open source tools which are behind the system, like Proj4. An example of the advanced functionality, which is kind of like available in the portal but slightly hidden. On the right side, if you search, are facets. So the system gives you not only coordinate reference systems, which you can filter, just like give me only geodetic coordinate system or give me only projected. You can search also for datums used in the given area or with a given name for the areas which are defined in EPSG. In fact, most of the people think that EPSG number defines just a coordinate system, but in fact, it defines all of these objects. So there is EPSG code for transformation, EPSG code for ellipsoid, EPSG code for unit, for area. All of these have their EPSG numbers. So it's not only coordinate system, which are mostly used by programmers in the computer world, where you say, okay, I have EPSG 4326, and it defines what coordinates are your data in. But it's also all the other features in the portal or other objects. Through CPSGR, you can discover them all. The other what you see here on the image is the list of transformations. One EPSG code, like this one, 5514, doesn't necessarily tell you the transformation methods. There are more transformation methods between the datums, between the ellipsoids, which can be assigned to a single EPSG code. So the EPSG code doesn't necessarily give you the equation for the transformation from one system to another. There you must use one of the transformations. In special reference org, this was missing, and these may give you wrong results if you apply wrong transformation on the data. You may be shifted by the ellipsoid transformation up to like 25 meters or even more on a wrong place. So this is quite an important thing, in fact, to know. If you know that your data are in given EPSG code number, what is the transformation? The transformation are typically there are three typically used transformation types at least implemented in Proj4. One of them is 3-parameter transformation, which is this little 3. There are other with 7 parameters, and there is a grid shift file. The grid shift file is the most precise for the location. Those are just 3 numbers, 7 numbers. Grid shift file is in fact a matrix, so a binary file which you need to have on your computer, and this defines the transformation in the absolute numbers. But with grid shift files, you can correct local mistakes, for example, made on old maps when people were measuring from one hill to another and doing triangulation. All of these things are not mathematically describable with an equation. You need to have the data which tells you, okay, here was a certain mistake which is local, and here was another mistake caused by another error during the measuring back in the time. So for this, the grids are important. The EPSGIO gives you a list of all these transformations for the given EPSG code. Oops. In fact, you can click on any of these, and those are aligned to the area. If you click on one of these transformations, in fact, the URL will change, and you get the new Proj4 definition and a way how to use the Proj4-based software for the transformation. So in this moment, if we click on Slovakia, you see the area is adjusted, but we have 1 meter accuracy instead of 6 meter accuracy, which would be with the 3-parameter transformation, just because we switched to the 7 parameters. Down on the page, you'll find again the definition of the coordinate system, so you can use it in different systems. So that was another use case, or in fact a reason why we started to work on this together with the full text search. The other thing which is quite interesting is all these features are in fact clickable, so you can explore link from coordinate system into ellipsoid. So now you are getting on a detail page of ellipsoid, the URL has changed, and you can study how the ellipsoid is defined, how the sphere is deformed to an ellipsoid, what are the parameters. An alternative way how to use the portal is in fact, like let's say you want to see a list of all prime meridians. If you look for Greenwich and you delete a query and make a query just with kind prime meridian, you will get all prime meridians, all 14 prime meridians which are defined in EPSG database. And you can preview this one, and the same to do with all the other types inside of EPSG. Okay, why we created EPSG in the beginning? It's for map tiler users, where map tiler is a software which creates tiles and map services by pre-processing the raster data, and people, when they drop in the file, it's automatically detected from the file itself if it contains coordinates. But if it's not, then they need to search for the coordinate system and identify it. And this interface was the reason why we started to work on EPSG-IO. The user interface is in fact using Search API on the EPSG-IO website, which is documented on GitHub, and anybody can use it for his own software or websites. And there are third-party applications already, like open source QGIS plugin using this EPSG-IO API, just doing the same search system in the coordinates. There is also a transformation API on the website, but it's kind of like experimental. It's just calling Proj4 on our server. So the same thing what you have seen in the graphical user interface on the website for transformation of a pair of coordinate to another pair can be done through calling on HTTP endpoint. Again, documented, but please don't use it heavily. If you want to transform something, like you have a list of coordinates you want to transform, I would recommend to use GDAL transform utility on the command line, which is probably one of the easiest for this particular task. And you can just copy and paste the Proj4 definition, put in parentheses, and supply the list of coordinates, and it gives you the results. So it's quite easy. In fact, if you want to use it in a scripted way, like you write Python script or any other scripting language, there is OGR library which is able to do exactly the same transformation. The EPSG-IO source code is available on the GitHub. It's completely open source, BSD licensed, powered by Python, Proj4 OGR, and you need the raw data, which are freely available from EPSG registry. In fact, it's prepared to run offline and very easily installed on a notebook. Especially if you have a Docker, it's just a single command. So once you have Docker on your Linux, you just run docker run clockantech EPSG-IO, and the system will start automatically. And you can use it on localhost without having access to the internet in an offline environment, including the APIs and the stuff, everything what is on the website. It's a complete copy of the website. If you are not familiar with Docker, there is graphical user interface called Kitematic. So if you download Kitematic or from docker.com, the graphical user interface, just search for EPSG and it will run the same way. Installation from the source code is of course possible as well. Future. We would love to bring grid shift files to Proj4 transformation, so it would be possible to have high quality transformation inside of a web browser, and there must be somehow a centralized web point where the grid sheet files are stored and pre-processed for web processing. So this is something what is on our roadmap. It would be amazing to work further on processing of the data and join the effort between different open source projects and different implementations of the database, which are now different on different open source projects. So there is, for example, EPSG database copy inside of libtiv, another EPSG copy through comma-separated value files and sort of hex in GDAL, another distributed with QGIS and other software tools. It would be great, and this was either already once discussed on the OSGeo forums, to have like a single SQLite, a packed database of the EPSG reusable by different tools. And I would love to work on this with somebody else and with the community to make this happen, simply. Because I think it will make the upgrades of the EPSG database in all the open source tools easier, and EPSG-IO may be one of them. it would be also amazing to have a system which is versioning the data on top of GitHub. So we have a repository where all the EPSG codes are stored and versioned, and you can make upgrades and corrections on GitHub directly with the versions. Recently, Esri published on GitHub their official Esri Proj definition codes, which I would love to merge as well. In this moment, we are using in EPSG.io the GDAL version, which is quite old, I believe. So the latest version is on GitHub of Esri, and it may be incorporated in the portal. And those are the things I would love to really discuss with somebody and work on it further. So thank you a lot. If you are interested, so a demo or advertising for another presentation, on Friday we are going to speak about vector tiles, including vector tiles with custom coordinate system. So from our team, meet us on Friday. Thank you a lot. If there are any questions, we'll be glad to answer.
Yeah, thank you, Peter, for an excellent presentation. Do you have any questions? Yeah, we can.
It might be slightly off topic, but my first question is, who actually maintains the EPSG codes? Obviously, the answer would be EPSG, I think. But connected to that, my second question is, what if the code is wrong? We encountered in the Netherlands for a long time that the parameters was missing one parameter. Mm-hmm. But it seems very difficult to fix that. So I was curious about your ideas on that.
Well, the official way is to go choose the official path, submit them emails, and push it through the official channels so it's distributed to everybody. That's exactly why it would be great to have the kind of like GitHub where you can make a pull request and it's versioned and reviewed by somebody, by a community, or accepted and then distributed to all open source projects. That would be the data EPSG future, and that's exactly one of the reasons why to make it. So in this moment, you have to officially contact the OGP or EPSG group and submit them the requests, and then it goes through the formal review, and it comes to a next version of EPSG database. I don't know how hard is it. We were not doing this. I mean, yeah, okay. Yeah.
Okay, yeah, we have one more question.
Hi. While using one of the coordinate system, I couldn't figure out what parameter defines area of validity for certain projection. You see a bounding box, and I couldn't figure out where is this, how it is defined, area of validity for.
So there are EPSG codes for areas, and in fact the areas have even polygons, which we don't display in the portal in this moment. We just display basic bounding box, but there are polygons for each area. Each area has EPSG code, and the EPSG codes of the ellipsoids and coordinate systems, projected or geodetic, are assigned to the areas. The code of the area is part of the definition of the coordinate system, or the transformation, or whatever is in the EPSG.
Okay, are there any more questions? Peter? Okay, so
thank you.
We'll give Peter a hand.